Based on the arrangement of its constituents, solids are broadly classified into two categories. They are crystalline solids and amorphous solids. Crystalline solids have an orderly arrangement of their constituent particles, such as atoms, ions, or molecules, in 3 dimensions. They are arranged in an orderly manner to give a definite geometry to the crystal. Thus, a crystal is defined as a solid figure that has a definite geometrical shape, with flat faces and sharp edges. Quartz and sodium chloride are examples of crystalline solids. Now let's discuss amorphous solids. The term amorphous has been derived from a Greek word, omorph, which means shapeless. An amorphous solid consists of a number of constituent particles arranged in a random manner. Thus, amorphous solids do not have any definite geometry. There is short-range order, which means that there is an irregular arrangement of particles that repeats itself to a certain extent only. Glass, rubber, and plastics are examples of amorphous solids. In many respects, these solids resemble liquids. They flow very slowly at room temperature and are regarded as supercooled liquids in which the forces holding the molecules together are so great that the material is rigid, but there is no regularity in the structure. The flow of these solids is clearly observed in glass panes fixed to the windows or doors of old buildings. These are found to be slightly thicker at the bottom than at the top. The best example of crystalline solid is quartz, and of amorphous solid is quartz glass. Their arrangement is shown here. From these two images, you can clearly observe that both solids have similar arrangements. However, in quartz glass, there is short-range order. A crystalline solid has a sharp melting point. That is, when it reaches its melting point, it immediately changes into liquid form. These are considered true solids. Amorphous solids do not have sharp melting points. These soften over a range of temperature and can be molded and blown into various shapes. These solids behave as crystalline at a certain temperature. These are considered pseudo-solids or supercooled liquids. Crystalline solids are anisotropic in nature. In other words, some physical properties like refractive index and electrical resistance change along with the change in the direction of the solid. This is due to the ordered molecular arrangement in the solid. Amorphous solids are isotropic in nature. In other words, they show the same physical properties in all directions. This is due to the random arrangement of the solid. If a crystalline solid is broken into pieces, the small constituents will have the same smooth and plane surfaces. Crystalline solids have definite heat of fusion values, while amorphous solids do not. Another important property of these solids is symmetry. Crystalline solids show plane of symmetry, axis of symmetry, and center of symmetry. On the other hand, amorphous solids do not show any symmetry.